All right, so if you're still confused on how to do a problem like number 57 from the homework, where we have some angle, and it could be 25 degrees, it could be 45 degrees, it could be anything between 0 and 90. And we have an unknown initial velocity, and we have the range is the only other number besides the angle that's provided. So we have this piece of information and we have this piece of information. Here's the general procedure for how to go through it. The first thing that you have to recognize is that we can substitute this variable v naught into a couple different equations because it's not in any of our equations. So we have to substitute it in using our cosine of theta and our sine of theta. So in our equation that we use to find range, this is just, in other words, this one would be, one second. This would be delta d or delta x is equal to vx times t. So this is just coming from that equation, d final is equal to vt plus d initial. We know that that's the same thing as saying delta d is equal to vt. And now instead of saying delta d, we're saying that it's the change in the horizontal position, which is the horizontal velocity times time. And then delta x is also known as range, or r, and so that's where this equation is coming from in the first place. So I can substitute Vx for V naught cosine theta, which is exactly what I've done in that equation. But I still have the t in that equation, and I don't know what t is, so I need to be able to find something else to put in for t. I'm going to do that using an equation on my acceleration side, on my vertical side. So I've got this equation that's equation number 1 from your toolbox. V final is equal to V initial plus AT. One thing that's very important is to remember that this velocity is my final vertical velocity. So that's my VFY is what this one is. And this one is my initial vertical velocity. And remember that final vertical velocity is equal to negative initial vertical velocity. And I need that so that I can do this equation here, which I like to call the sexy time equation, just to remember a specific equation. So this is just coming from this situation here. So I've substituted in for VF, I substituted in the negative VIY, so that's this part right here. That's my negative VIY, is equal to VIY plus AT. And then I solve that for time, I get negative 2 VIY over A. Okay, so then I need to substitute in for VI, I need to substitute in my V naught sine theta, because I know that that's how I'm going to get that vertical component of my velocity over here from V naught. I'm going to multiply V naught times the sine of theta, because this is my hypotenuse and then this is my opposite leg. So I do V naught sine theta. I plug that piece of information into the sexy time equation. So I'm taking this piece and I put this piece in for this piece here. So then I get negative 2 times V naught sine theta, which is, this piece right here, is VIY over A, which is negative 9.8. So the only thing that I don't know here is V naught, because I know that sine theta is whatever angle they give me, in this case 25, just because I picked 25 randomly. It was 45 in problem 57. And I also know that A is negative 9.8. So one thing to remember is that since this is negative 9.8, that negative will cancel with this negative right here. So this whole term will become a positive number. So now I'm taking this entire term here and I'm plugging it in to my equation that I had here. So this is still my range, or my change in horizontal position, is equal to my horizontal velocity times time. So I've plugged in for my horizontal velocity v naught cosine theta, and I've plugged in for my time this whole piece that I solved using the sexy time equation up here. So plug that in. Then I need to reduce and solve for v naught. So I'm going to take my negative 2, still going out in the front. Then v naught has to be squared because I have a v naught here multiplied by v naught again. Then sine theta times cosine theta, so sine theta times cosine theta, still divided by a. And if you're good from here on how to solve this, then great. If you're still not totally sure what you would do next, I'll go ahead and go through the next steps and you can watch. Okay, so I have delta x is equal to negative 2 v naught squared times sine of theta times cosine of theta. All of that divided by a. The easiest thing for me to do at this point would be to just get rid of my acceleration. So I will multiply both sides times acceleration. Okay, so now I'm going to get acceleration times change in x is equal to negative 2 v naught squared times sine theta times cosine theta. Okay, so now I still need to get v naught by itself, and it's being multiplied by this negative 2 and by the sine theta cosine theta. So please watch out for using your correct operation to get the negative 2 and the sine theta cosine theta to the other side. You're not subtracting anything, you have to divide them. So I'm going to divide by negative 2, divide by sine theta cosine theta on both sides. Okay, and so all of this will now cancel out, and I will be left at this point with a times delta x is equal to, or over, negative 2 sine theta cosine theta is equal to v naught squared. So to finally get just one v naught, I need to take the square root of both sides. So then I will be left with the square root of a times delta x divided by negative 2 sine theta cosine theta is equal to v naught. So that's how I would solve for my initial velocity in a problem like this.